Welcome to Brain Vision.
In the first item, begin by remembering that the speed of the photon is equal to its wavelength times its frequency. Therefore, the wavelength of a photon is equal to its velocity divided by its frequency. And also, remember that the velocity of a photon is always equal to the speed of light, c. Therefore, lambda is equal to c divided by the frequency. And this is the equation we will be using. But now, how can we calculate the frequency? Well, remember that the energy of a photon is equal to the frequency times h, Planck's constant. Therefore, the frequency is equal to the energy divided by Planck's constant. Then, we can plug in this result in this equation to solve for the wavelength. To get the following: lambda is equal to c times h divided by E. Now note that the energy that is present in this equation is the energy of the photon, and the energy of the photon is equal to the difference between the energies where the electron was and where the electron now is. So it is the transition energy of that electron. In order to have the longest possible wavelength, we must have the smallest possible transition energy. And the smallest possible transition energy, as we can see from this equation, happens in the transition from state 2 to state 1. And what is this transition energy? So we can use this equation to calculate. We get the following: E2 to 1 is equal to E2 minus E1. And E2 minus E1 is equal to m squared is equal to 2 squared 4 minus 1 squared is equal to 1 times the common factor of h squared divided by 8ml squared. And this is equal to 3 times h squared divided by 8ml squared. But this is not the whole thing. Note that this is equal to E1, and E1 is equal to 9 electron volts. Therefore, the smallest possible transition has an energy of 3 times 9 electron volts, which equates to 27 electron volts. Therefore, the longest possible wavelength is equal to c times h divided by 27 electron volts. By substituting the values that were given, we get the following: c is equal to 3 times 10 to the 8. H is equal to 6.63 times 10 to minus 34. And this is divided by 27 electron volts. In order to get the wavelength in meters, we have to plug in the energy in joules. So we have to convert from electron volts to joules. In order to do so, we have to multiply the energy in electron volts by the electron charge, which is equal to 1.6 times 10 to minus 19 joules by electron volts. So we get the following: 27 times 1.6 times 10 to the minus 19. And finally, this is approximately 4.6 times 10 to the minus 8 meters. And this finishes the first item. Now, in the second item, we have to calculate what is the width of that well. So in order to do so, we use this equation, which is the equation for En, and solve this equation for L. By doing so, we get the following: En is equal to n squared h squared divided by 8ml squared. Then we can send the L to the other side. So we get L squared is equal to n squared h squared divided by 8m En. And finally, L is equal to n h divided by the square root of 8m En. Now, we have to do the following. We have to plug in the given values to solve for L to get a numerical value. So L is equal to, we have E1, so N is equal to 1, then L is equal to H divided by the square root of 8 m E1. And this is equals to 6.63 times 10 to minus 34 divided by the square root of 8 times 9.11 times 10 to minus 31 times E1. E1 is equals to 9 electron volts. But in order to get the L in meters, we have to convert the energy from electron volts to joules. We do so, again, by multiplying the energy in electron volts by the electron charge, which is 1.6 times 10 to minus 19. And this gives us a width of approximately 2 times 10 to minus 10 meters.